So we are going to start with vertical angle proofs. You should have this page open in front of you. So first it says name all linear pairs and then name all vertical angles. So remember that linear pairs are two angles that form a line. So here, two angles that form a line. Okay, if I look at that line right there, I have angle 1 and angle 3. Or 1, 2, I'm sorry. So angle 1 and also angle 2. Then angle 4 and angle 3. If I look as well here, there's a line right there. So then making up those two angles, angle 1 and angle 4, and then angle 2 and angle 3. The next says name all vertical angles. So vertical angles are directly across from each other. So like 2 and 4. So angle 2 and angle 4. And then also angle 1 and angle 3. So recognizing linear pairs and vertical angles are going to be very important through this section so that way we can figure out what we need to do in order to solve the problem. The vertical angle theorem. So it says if two angles are vertical, so they're directly across from each other, then their degree measures are congruent. So all vertical angles should have the same degree measure. So if I look back up here, angle 2 would then be congruent to angle 4, and angle 1 is then congruent to angle 3 because they are vertical angles. All right, so we have a proof. So it says proof of vertical angles theorem. We are given that angle 1 and angle 3 are vertical angles. So we are given that this angle and this angle are vertical angles. Let's go ahead and prove that the measure of angle 1 equals measure of angle 3. So now I'm going to prove to you that vertical angles do have the same degree measure. So always starting off, we're going to start off with what we're given. So we are given here that angle 1 and angle 3 are vertical angles. And that is given. Okay, the next reason says definition of linear pair. So I know that a linear pair make a straight line, and we also know that a straight line has a degree measure of 180 degrees, meaning two angles that make a linear pair, their degree measures should add to be 180 degrees. So for example, if I look in this picture, I know angle 1 and angle 2 are a linear pair, so they should add to be 180 degrees. So let's try that. Measure of angle 1 plus measure of angle 2 equal 180 degrees. Okay, and then I also know that if I look here, 2 and 3 form a linear pair. So measure of angle 2 plus measure of angle 3 equal 180. And that will also be definition of linear pair. Now this is where the rest of the proof we have to fill in ourselves. Okay, so here, if I have, for example, I'm just going to write this off to the side. If I have measure of angle 1 plus measure of angle 2 equal 180, and I also have measure of angle 2 plus measure of angle 3 equal 180, they are both equal to the same thing. Okay, if they are both equal to the same thing, that's the overlap. So this is going to be the transitive property, and this is where the transitive property is used the most. So if they're both equal to 180 degrees, then I can go ahead and set these two statements equal to each other. So let's go ahead and set that measure of angle 1 plus measure of angle 2 is then equal to measure of angle 2 plus measure of angle 3. And again, that is the most popular way that the transitive property is used. So this is going to be the transitive property. All right, and then the last line should always be what we're trying to prove. So I'm trying to prove that measure of angle 1 equals measure of angle 3. And how did I get there? Well, I see this line has measure of angle 2 being repeated. So then I can subtract it out, and that's going to be the subtraction property of equality there. Alrighty. Next, if we go to the back, we are going to be finding missing angles. So we did some of this in Unit 1, but we really focus on it in Unit 2. So again, some of these, I'm sure, number 1, you've already been quizzed over a little bit to be able to figure out the different angle measures, but some we have not looked at. So number 1, I'm going to say measure, oh my gosh. Okay. Measure of angle 1 is measure of angle 2 and measure of angle 3. Okay, so let's first start. I know 1 and 40 degrees share or form a straight line, which means they are a linear pair, or they add to be 180 degrees. So a measure of angle 1 will then be 180 minus 40, or 140 degrees. Okay, and I'm also going to put that up here in my picture. It can never hurt to label a picture. Measure of angle 2, well, 2 and 40 are vertical angles, so they are congruent. So measure of angle 2 is 40 degrees. And then measure of angle 3, I can also see here that 40 and measure of angle 3 are a linear pair, or I can see 140 and 3 are vertical angles, so they have to be congruent. So this is going to be 140 degrees as well. All right, now problem like number 2, so there are going to be a few steps here. Notice how both of our expressions, they are vertical angles. So vertical angles have the same degree measure, so I can go ahead and set their degrees equal to each other. So 2x plus 40 should equal 5x plus 16. Subtract 2x over 2x. 40 equals 3x plus 16. Then I would get 24 equal to 3x, and then x will equal 8. Okay, but that's not what we're trying to solve. I'm trying to solve for my question mark. So that means I can go ahead and plug x back into one of my angles. So 5 times 8 plus 16, that is 56 degrees. So this angle right here is 56 degrees. And then once I find out that angle, I can use my knowledge about linear pair to solve for my question mark. So then I'm just going to take 180 degrees, subtract 56, and I get 124. So then this angle is 124 degrees. So that's an example where you have two vertical angles, and we can go ahead and set those expressions equal to each other. In number 3, we have an example where they form a line, And again, when two angles form a line, their degree measures should add to be 180 degrees. So I can set these two expressions, I can add them together and then set it equal to 180. So if I have 2x minus 2 plus 6x plus 8 equal to 180 degrees, combine like terms, I get 8x plus 6 equal 180. Okay, so 2 plus 6 is 8, minus 2 plus 8 is positive 6. And then solving, I can subtract 6 from both sides. 8x is equal to 174. Divide by 8, and x is equal to 21.75. Okay, and then to go ahead and solve for our two angles, I'm just going to plug x back into each of my expressions. So 2 times 21.75 minus 2 is equal to 41.5. So that means that this angle right here is 41.5 degrees. And then the same thing with the 6x plus 8. So 6 times 21.75 plus 8 will equal 138.5. So this angle is 138.5 degrees. And we can also check that because 138.5 plus 41.5 does equal 180 degrees. All right, 4 and 5. So going through these, I would definitely try to recognize where your common variables are. Okay, so group together your x's and then group together your y's and try to solve based off of that. Looking at number 4, we have an x and a y in each expression, meaning we will not be able to do that, which is fine. Okay, so you need to create two separate equations, and from there, we are going to use the systems of equations to solve. So number 4 is definitely a challenge problem. I think that people can still definitely use or be able to solve this problem. However, it is a challenge problem. So if you don't fully understand, it's okay. It pulls from Algebra 2 or Algebra 1, but it is a challenge problem. Okay? So bear with me when going through it. So first I'm going to look at those two angles right there. They form a linear pair, so I'm going to go ahead and add them to be 180 degrees. So I have 3x plus 2y plus x plus 6y minus 4 is equal to 180 degrees. Okay, so let's go ahead and combine like terms. So 3x plus x is 4x. 2 plus 6 is 8. And then minus 4 is equal to 180 degrees. All right, and then I'm going to have a different equation. And I'll go ahead and use blue for that one. So my other equation is going to be these two. Now you could use vertical angles here. It's okay if you don't. So I can go ahead and say that x plus 6y minus 4 plus x plus 10y minus 4 is equal to 180 degrees. Again, combine like terms, I get 2x plus 16y minus 8 is equal to 180 degrees. Okay. Now, again, this is a systems of equations, so you can use your methods of elimination, you can use your methods of substitution, So whatever you need to be able to solve this equation, I'm going to go ahead and use substitution, meaning I am going to solve for a variable in one equation and then plug it into the other equation. So here I'm going to take my equation over here in black, and I'm going to go ahead and solve for x. Okay, so looking at this, I'm going to solve for x. So I'm going to get everything over to the left side of the equation except for my x variable. Okay, so I'm going to subtract 8y, and I get that 4x minus 4 is equal to 180 minus 8y. Add 4. 4x is equal to 184 minus 8y. Divide by 4. When I divide by 4, I need to divide on each number. So 184 divided by 4 is 46. And then negative 8 divided by 4 is 2. Okay, so now I solved this equation for x, and I'm going to plug it into my new equation. So here I have 2, and then I see an x, so I'm going to pause, plug in 46 minus 2y. 46 minus 2y, and then I'm going to continue. So plus 16y minus 8 is equal to 180 degrees. I can then distribute. 2 times 46 is 92. 2 times negative 2 is minus 4y. Plus 16y minus 8 is equal to 180 degrees. Now my equation is all in terms of y, and I don't have a mix of x and y in my equation, so I can go ahead and solve. Combining like terms, 92 minus 8 is 84. And then minus 4y plus 16y is plus 12y is equal to 180 degrees. Subtract 84. 12y is equal to 96. Divide by 12. Y is equal to 8. And then I'm going to come back over here to my x equals equation and use y to solve for x. So then x will equal 46 minus 2 times 8, or x is equal to 30. Then when I plug back into my equations here, so 3 times 30 plus 2 times 8 is going to be 78 degrees. Oh, it is not 78 degrees. It is 106. Where did I get 78? 106. Okay, so this angle is 106 degrees. That means this angle is 106 degrees. And then 180 minus 106 will give me 74 degrees. Okay, so again, that was a challenge problem. You can still attempt it to at least set it up, get as far as you can, try it. I would rather have you try a problem like this than just sit there and skip it because you think it's too hard. You will be surprised at how far you can get in a problem like this. Okay, but number 5 is a little bit better because number 5, group together your like variables. Okay, so I have y's right here and I have x's right here. Well, good thing they both form a linear pair, so I can go ahead and add them together and set them equal to 180. So then 3y plus 11 plus 10y is equal to 180 degrees. So 11 minus 7y is equal to 180 degrees. This should be plus, which is going to change this. Okay, so plus 10y, so it should be 13y plus 11 is equal to 180 degrees, minus 11. 13y is equal to 169, and y equals 13. And then the same thing with our x's. They form a linear pair, so we can add them together and set them equal to 180. So then 7x plus 4 plus 4x minus 22 is equal to 180 degrees. 7 plus 4 is 11x. 4 minus 22 is minus 18, equal to 180 degrees. Add 18 to both sides. 11x is equal to 198 divided by 11, and x is equal to 18. And then once we plug these back in, we can solve for our angles. So then we have 10, if I look at this angle, 10 times 13, which is equal to 130. That means this angle is 130 degrees because they are vertical. And 4 times 18 minus 22. So 4 times 18 minus 22 is 50 degrees, and this angle is 50 degrees. And again, they should add up. So 130 plus 50 is 180, so we are good.